congratulations. Until now we finished the first 4 paragraph knowledge learning for algebra and symbolic math with SymPy. From this video, we will talk about these 4 programming challenges, starting from the first one, factor finder. So it's kind of our simple calculator that we will do. So let's read the instruction. So we learned factor function in this chapter, which can print the factor of an expression. Now we know is how the program can handle expression input by user. So the expectation is write a program, ask user to input an expression, calculate the factor, and the printer print them. Your program should be able to handle invalid inputs. So we have learned that quite a lot. So let's try to practice our learning. So let's create a 451. Call this factor finder. Not py. Com is the py. So let's make our header. So purpose is the factor finder using the factorizer. All this, not using factor function. Then this, you can put this yourself the name and the dates. Now, as first let's see. So we need our the symbol. We need the expression. We need the factor. So from SymPy, what we need to do that is we need a symbol actually. So that is the first one. But whether we need to do that. If we don't need to identify the specific variables, the symbol is not our the mandatory things. So first is definitely we need the factor, let's see. And we need user input, so we need the simplify. So that is one. And we also need this simplify arrow. So let's do this if name. Then we will need the user's inputs with expression. So inputs is the input one expression. For factorizing. And then we will practice our try the expression equal to simplify the expression. So we will do this. So we just maybe it's we just use this, and then the except simplify arrow, then print invalid inputs. So let's now do our testing. So we got this prompt, then it's let's see 2x plus 1. So that's not valid. So compared to the last one, so we did is this one. You see, we use the simplify call SymPy call simplify to load this simplify arrow. But looks like is if we ignore those part is simplify arrow also available directly in SymPy. So that is the either way is working. So just else we will do the make our, let's do this print. Oh, sorry. So it should be in the same line. And then this tab. Print is factorize the over express. So then we need to write down over factorize express function. So for this one, it's very easy, just one line. So we return factor of the express. So that is done, I think. So is any return factor? So let's save. See any. So 2 times. Let's see the x times x minus 3 times x plus 5. Oh, there's no a way to do this the factorize. Let's do this for x times x plus 5 times x. Oh, x times x. So x squares plus 5x plus 6. I know this can be factorized. Okay, that's the perfect. So if it can be factorized, it will show this factorized result. If it's already the most simplified, it just show the origin. But I noticed that here I have a typo error. So let's correct this. So that is the first challenge. Is just as a recap, is we practice this user inputs, then we read our expression. Because we don't use those variables inside this expression like this x, so then this we don't need to use a symbol, so we don't need to define that. So we only need to load simplify to help us do this string to the expression, this conversion, and we load this simplify arrow, and we discuss this also available directly under SymPy. So we load this, and we can use a try except simplify arrow to handle these invalid expression inputs. Then through the else this branch, we do this the customized factor this function. So because this is just our the simple function, so if you don't define this, you can directly put here is a factor. That is also the correct. So, but let's try such kind of the program structure. You define some own function, and from your the primary the code you code your function and transfer the arguments there, so that you can utilize those argument transfer mechanism. So that is for this first programming challenge. I hope is you also practice that and get different testing from the arguments or from this kind of the inputs. So if, for example, if I put here x times x plus 5 times x times y, I have a 2 plus 6 times y times y. So you can see here, it's not care about how many variables you are using. So they just do this factor for you. So and remember is this expand is the inverse, the processing for factor. So if you do this to this kind of expression with the expand, then you back to this original the expression. Okay, so thank you for your watching to this video, and see you in the next one. We are talking about how to do the graphical equation solver. Thank you. See you then.